Hello everyone and welcome to the chapter number 50 of Blender Master Course, Geometry Nodes, Part 1 of Creating a Lighting Scene. In this chapter and the upcoming chapter, we'll be learning about lots of new geometry nodes and we'll be using them in order to create this lighting scene. For today's chapter, our target will be to understand all these topics in complete detail and begin with the creation of this lighting scene. And for those of you who are new to this course, you can check out the previous 50 chapters from the link of the playlist in the pinned comment. Now, first of all, let's go to the Geometry Nodes workspace, and the first topic for today's chapter is understanding the gradient texture node. So for this, first I'll delete this cube by pressing X. Then press Shift plus A, go to Mesh, and let's add a plane object in the scene. Now to understand about the gradient texture node in the geometry nodes, we first need to understand about the same gradient texture node in the shader editor. So for this, click here and select the shader editor from this list. Click on the new button, and to add the gradient texture, simply press Shift plus A, then go to texture, and from here, select the gradient texture. We'll place it over here, then press Ctrl plus T to add the texture coordinate and the mapping node. Then as usual, take the object socket and connect it to the vector. And to view the output, first of all, let's go to the render view, and to apply the gradient texture, hold down Ctrl Shift and left click on the gradient texture node. Let's also go to the top view by pressing 7 on the numpad, and just like the name suggests, the gradient texture node simply gives a gradient as the material. Now instead of understanding it in terms of the colors, let's also try to understand in terms of mathematical values. So with this gradient texture applied, the value will change from -1 to 1 in the same direction where the color changes. Initially, at this position, the value is -1, and I have explained it to you a lot of times that whenever the value is less than or equal to 0, then the color which is assigned is always the black color. As a result, at this position, we see that the color is black, then the value increases from -1 to 0. So even at the value of 0, which is at the center, the color is black, and then the value begins to increase from 0 to 1. And since the value is getting increased from 0, as a result, we see a shift in the color from complete black to the white color. Now let's also understand the gradient texture node in the geometry nodes editor. So for this, click on this icon again and select the geometry nodes editor. Click on the new button. To control the size or the number of vertices of this plane, press Shift plus A, go to Mesh, then in the primitives, select the grid node, place it over here, connect the mesh socket to the group output, and you can also see that by adding the grid node, the material that we applied, which is the gradient texture, has also disappeared. And that's because whenever we add any object using the geometry nodes, then in that case, we need to use the set material node in order to assign the same material. But for now, we won't be assigning any material to this plane. Let's also go to the solid mode, and now before adding the gradient texture node in the geometry nodes editor, let's also add an extrude mesh node. So press Shift plus A, go to mesh, then in the operations, select the extrude mesh node, place it over here. It looks like a cube because it has extruded the face depending upon this offset scaling value. But suppose you want that instead of adding any particular number here, the offset scaling should instead depend upon the gradient texture. So let's try to do it. So press Shift plus A, then go to texture and select the gradient texture. Place it over here, connect the color socket to the offset scaling, and you can see that we got some unexpected result. Also, let's do one more thing, which is to increase the number of vertices of this grid to something like 50. I'll also increase the size in order to view it properly. So I'll change it to a value of 5 meters, and now this is how our plane is looking after connecting the gradient texture to the extrude mesh node. Now to understand what exactly is happening here, hold on Ctrl Shift and left click on the gradient texture, and then similarly left click on the grid node. Now you can see here that the viewer node is only connected to the grid node and the gradient texture, and as a result you get the same result that we saw while understanding the gradient texture in the shader editor. Now just like before, the value at this part is equal to -1, then in the middle it is 0, and in the end the value is equal to 1. Also, if I again hold the Ctrl and the Shift button and left click on the extrude mesh node, then now this viewer node is connected to the extrude mesh and the gradient texture node, and you can see here that the color is changing from complete black to the white color. As a result, in this case also, the value on this part which is touching the bottom is equal to -1, then as it approaches the middle, the value increases to 0, but since the value is still less than or equal to 0, as a result it is still black colored, and as soon as the value becomes positive, the color again changes to white. Similarly, this gradient texture connected to the offset scale initially gives a value of -1 to this part. As a result, the extrusion gets applied in the opposite direction, then as it approaches the middle, the gradient texture sends the value of 0 to the offset scale, and therefore this middle part is not extruded, and then again as it approaches the end, the value increases to +1, and therefore the offset scale will be positive, and therefore the extrusion is seen in this upward direction. So in simple words, the gradient texture changes the value of the offset scale from -1 to a value of +1. Now you can also see that this gradient texture node has some gradient types. For example, the linear, quadratic, easing, and with each one we get a different type of result. For example, if I select the radial, then now you can see that the value changes from this point in the radial direction. direction. In simple words, if I go to the top view by pressing 7 on the numpad, then over here the value is equal to 0, then it increases like this, and in the end the value is again equal to positive 1. Also, if you look closely, then the extrusion is also getting applied in a similar way. On this part over here there is no extrusion, and so it is completely flat. Then as we approach this end, we notice some slight extrusion. Similarly, on this part there is some more extrusion, and as it approaches the end, the extrusion effect even increases more. So in this case, with the radial gradient type selected, the value changes from this point in a radial direction, and in a similar way the offset scaling in the extrude mesh node is also changing. Now if I go to the top view by pressing 7 on the numpad, and suppose you want that instead of the gradient texture being applied only once, it should be repeating itself, then for this we need to use the math node with some specific operations. So press Shift plus A, go to utilities, and in the math category select the math node, place it over here. Let's also connect it to the offset scale, and now if I click on the operations list, then over here we have this ping pong operation. So I'll select it, and by using this operation I can control the value at which the gradient texture ends. So initially the value will still be equal to 0. However, whatever value I insert in the scale here will get applied as the ending value. For example, if I change the scale to 1, then in this case the value is changing from 0 to positive 1, that is from the black color to complete white color. However, if I reduce the scale to something like 0.5, then in this case the value will change from 0, which is black, to a value of 0.5, which is a mix of black and white, or simply the grey color. So for now I'll change the scale back to 1, then create a duplicate of this node and place it over here, and we'll be using this node in order to multiply this effect. So from the function I'll select the multiply, and then if I try to increase the value from here, then you can see that the effect of gradient texture is getting multiplied. So if I keep it to a value of 10, then in this case the effect of gradient texture is applied 10 times. For example, here the value will be equal to 0, then somewhere over here the color is completely white, and as a result the value will be equal to 1, then again the value decreases to 0 and the color changes to white, and it continues in a similar way. Also, if I try to change the view like this, then you can see that because of multiplying the gradient texture effect, the extrusion is also getting affected. So for now I'll delete the viewer node from here, and now this is how our plane looks right now. Now moving ahead, the next topic for today's chapter is understanding the RGB curves node. So for this, I'll add a plane in the scene. So press Shift plus A, go to mesh and select the plane. Let's move it in the x-axis over here. And just like the gradient texture node, we'll be understanding the RGB curves node first in the shader editor and then in the geometry nodes editor. So click here and select the shader editor. Let's also go to the render view. And now for understanding the RGB curves node, I'll also need the gradient texture node. So let's do one thing. I'll apply the same material that we previously used to understand the gradient texture node. So click here and select this material.001. In your Blender file, it might be possible that this material gets saved simply with the name material instead of material.001. Now just like we did in the geometry nodes editor, we'll be adding the math node with the multiply and the ping pong function. So press Shift plus A, go to converter and select the math node. Place it over here, change the operation to ping pong, change the scale value to +1. Then for the multiply, I'll create a duplicate of this math node and place it over here. Let's also change the function to multiply and change the value to 10. Let's also change the gradient type from the linear to the radial, and now it looks like this. Let's also go to the top view by pressing 7 on the numpad, and now finally we can add the RGB curves node. So press Shift plus A, go to color and select the RGB curves node. We'll place it over here. Now this RGB curves node is used to control the way the RGB channels look. For those of you who don't know what RGB is, it basically means red, green and blue color, and these three colors are the primary colors of light. By using different values in the RGB channels, you can create any type of colors. To understand it in a better way, let's add a color ramp node. So press Shift plus A, go to converter and select the color ramp. Place it over here, and you can see that over here the color mode is selected as RGB. Also, if I click over here and change it to RGB, then it allows you to input any value in the red, green and the blue channels, and depending upon these values you will be getting a unique color each and every time. So for example, if I take this color to the red color, then you can see that the other two values have changed to 0 and the value in the red channel is equal to 0.81. If I increase it to a value of 1, then in this case the brightness will increase. Similarly, if I select the second pointer and change the color to the blue color, then now you can see that the other two values, which is of the red and the green channels, is 0 or approximately equal to 0. You can try to change the position of this pointer in order to change the value to exact 0, and in the blue channel the value is equal to +1. Now if I take the RGB curves node and drop it after the color ramp, then in this case I can use this node to control the RGB channels. Over here you can see that we have 4 options: CRGB. C stands for the combined channels, meaning that if this one is selected, then we'll be controlling all the 3 channels collectively. Then the next one is the R, and this one will control the red channel. Similarly, G controls the green channel, and B controls the blue channel. Now if I click anywhere on the curve, a point or basically a handle will get created, and if I left click and drag like this, then the position of the handle will change and we'll notice some differences in the color. By moving this handle in the upwards direction like this, the brightness has increased. Similarly, if I take this handle and bring it down, then in this case the brightness will reduce, and this is how the colors are looking right now. So by changing the way this curve looks, you can control the way how the colors look on your object. Also, if I click anywhere else on the curve, then another point or another handle will get created, and I can use both the handles in order to modify the way the colors look in the material. If you want to reset all the things that you did here, simply click on this icon and select reset curve. So basically this is how the RGB curves node works in the shader editor. For now, I'll delete this plane from here by pressing X. Let's select this plane again, and now let's understand the RGB curves in the geometry nodes. So click here and select the geometry nodes editor. To add the RGB curves node, press Shift plus A, go to utilities, then in the color, select the RGB curves node. Now we'll drop it after the matte node with the ping pong operation. Just like before, if I click anywhere on the curve, a handle will get created, and if I try to move the handle, then you will notice that it manipulates the way the gradient texture was looking. So it completely depends upon you about how you want the texture to look on the object. Also, you can select the end handles over here by left clicking, and if I drag it like this, then the position of this handle will also change. So try to adjust the different handles in order to change the way the gradient texture, or basically the extrusion value, looks because of connecting the offset scale to the gradient texture. So for now, we'll be keeping it very simple. I'll bring down this end point over here, and by doing this, you can see that the height is also reduced. So there is no right or wrong curve which needs to be there in the RGB curves node. It completely depends upon you about how you want your scene to look like. So try to play with the different handles of the curve. Also, you can try to change the values in the math node and get different types of results. We can also do the same with this math node with the multiply operation, and we'll be getting some different results. But for now, I think that it looks perfect, so I'll finalize this. Now moving ahead, we'll now be creating some lighting in our scene. So for this, let's first go to the solid mode, and to create the lighting, let's add some random object in the scene. So press Shift plus A, go to mesh, and I'll select the plane. Let's move it in the Z axis over here, then go to the geometry nodes editor and click on the new button. Now to control the scaling of the plane from the geometry nodes, let's add a grid node over here. So press Shift plus A, go to mesh, then in the primitives, select the grid node, place it over here, connect the mesh socket to the group output. Let's increase the size to something like 2 meters or maybe 2.5 meters. Now to make the lighting, we'll be using some curve lines as the instances. So press Shift plus A, go to instances and select the instance on points, place it over here, and for the instance object, let's add a curve line node. So press Shift plus A, go to curve, then in the primitives, select the curve line node, place it over here, connect the curve socket to the instance. Now we have these curve lines placed as the instances on different points of the grid, and suppose you want that the end points of the curve line should be touching the nearest surface of this plane. Then for this, we have the sample nearest surface node, but to use it, we also need to add the set position node. So press Shift plus A, go to geometry, then in the right category, select the set position node. We'll place it over here, then press Shift plus A again, go to mesh, and in the sample, select the sample nearest surface node. We'll place it over here. Now the sample nearest surface node will sample any value of the surface which is nearest to the points of the curve line. Also, in the data type, you have many options like the float, integer, vector, and whatever you will select here, that particular data type will be sampled by the sample nearest surface node. Now we also have the mesh socket in this node where we need to connect the target mesh object, or in this case, this plane that we have added here. So go to the scene collection, left click and drag the plane into the geometry nodes editor, take the geometry socket and connect it to the mesh socket in the sample nearest surface node. Also, in the object info node, select the relative option, and now suppose you want that this value socket in the output should sample or basically generate the position of the nearest surface. Then for this, first of all, change the data type to vector, and then we'll connect the value socket to the position node. So press Shift plus A, go to geometry, and in the read category, select the position node, place it over here, connect it to the value. Now for the output, I'll connect this value socket to the position in the set position node. Now you can see here that the position of these curve lines placed as the instances has changed. However, it is still not perfect. If I select these curve lines and press G to move it, you will notice that we can't move them upwards. To fix this problem, we need to use the realize instances node. So press Shift plus A, go to instances, and from here, select the realize instances node. Place it in between the instance on points and the set position node. And also, if you remember, I told you that we needed only the end points of the curve lines to touch the surface of the plane. To achieve this result, we need to connect the selection socket in the set position node to the end point selection node. So press Shift plus A, go to curve, and in the read category, select the end point selection node. Place it over here, take the selection socket and connect it to the selection in the set position node. Since we need only the end point to be selected, so change the start size to 0, and now you can see that we have these curve lines added over here with the end points snapped snap to the nearest surface of this plane. Also, if I press G to move them, then they're also changing in the Z axis this time. And this is because of the realize instances node that we added after the instance on points node. Now since we'll be using these curve lines to make some thunder lighting in the scene, so we also need to add some distortion to it. Right now they're completely straight, and to add some distortion we need to add another set position node. So I'll select this one, press Shift+D to create a duplicate and place it over here. Now for the distortion we'll be using the noise texture added to the position node. So for this, press Shift+A, go to utilities, and in the vector select the vector math node, place it over here. Now we need to connect this node to the position socket in the set position node. So we'll connect it like this. Then for the two vector values we'll be using a position node and the noise texture node. So press Shift+A, go to geometry, and in the read category select the position node, place it over here, connect it to any of the two vectors. Then for the other one, let's add the noise texture node. So press Shift+A, go to texture and select the noise texture, place it over here, connect the factor socket to the vector. Now to apply the distortion effect properly, we also need to increase the number of control points in the curve lines. By default they have only two control points, one at the beginning, another at the end. So to add more control points we'll be using the resample curve node. So press Shift+A, go to curve, then in the operations select the resample curve node, place it over here. Now we finally have something which looks like the thunder lighting. However, if I try to move it down by pressing G, then you can notice that it's still not perfect. So to solve this problem, you simply need to change the value in the offset. So let's reduce it to something like -0.8 or maybe -0.5. And now if I try to move it by pressing G, then in this case the lighting looks much better than before. Now to make it look real, we also need to convert it into a mesh. So let's add a curve to mesh node. So press Shift+A, go to curve, then in the operations select the curve to mesh node, place it over here. For the profile curve we'll be using the curve circle node. So press Shift+A, go to curve, then in the primitives select the curve circle node, place it over here, connect the curve socket to the profile curve. Also let's change the radius to something like 0.1, and now to make it look like it has bigger radius over one end and smaller at the other, we'll be using the set curve radius node. So press Shift+A, go to curve, then in the right category select the set curve radius node, place it over here. For the radius we'll be using the spline parameter node. So press Shift+A, go to curve, then in the read category select the spline parameter node, let's place it over here, take the factor socket and connect it to the radius in the set curve radius node. Now since we need the bigger radius on the top and the smaller radius at the bottom, we need to invert the radius, and for this we'll be using a map range node. So press Shift+A, go to utilities, then in the math select the map range node, we'll place it after the spline parameter node, and to invert the radius simply change the 2 min value to 1 and the 2 max value to 0. Now to fill these top faces, go to the curve to mesh node and turn on the fill gaps. Also let's further reduce the radius in the curve circle node, so we'll keep it to something like 0.05, and now this is how the lighting scene is looking right now. Also if you want to increase their number, then simply go to the grid node that we added initially, and by increasing the number of vertices here, we can increase the number of curve lines that we used as the instance here. So let's go to the vertices option in the X and Y axis and increase it to something like 5. To place them apart, we can increase the size from here. So let's keep it to something like 3.2 or 3.3 meters. Let's also keep the number of vertices to 4 instead of 5, and this is how it looks now. And also if you want the lighting to look a bit different, then you can try to change the scale value in the noise texture that we added over here. So if I reduce it to something like 2.5 or maybe 2, then it looks like this. Also to increase the number of points, you can go to the resample curve node and increase the count value from here. Also to make the turns more sharp, you can go to the roughness value in the noise texture and try to increase it like this. And finally, I think that the thunder lighting in the scene looks perfect. We also arrived to the end of the chapter number 50. Today we learnt about some new geometry nodes and used them to create this simple scene. In the next chapter, we'll be using some more new geometry nodes to create some clouds in the scene and to finalize our lighting scene. So our next chapter will be the chapter number 51, Geometry Nodes, part 2 of creating a lighting scene. So don't forget to subscribe to our channel, press that notification bell so that you can get timely updates about the upcoming chapters. Thank you for watching, and we'll see you in the next one.